right, guys, today is Science with Miss Traver, and we are going to do a super cool experiment about something that we've been talking a lot about in social studies. So, somebody tell me, what is this object? What is this device? Callan, what is this?
A compass.
It is a compass, and we've seen this before, right?
Yeah.
We've seen this before on our maps, the compass rose. This is the handheld version of it. And does anybody know, can they raise their hand and tell me what they remember we use the compass for? What can we use the compass for? When?
Finding where to go.
Finding where to go. Would anyone like to add on to that? Avery?
So if you're like in the middle of nowhere, and then if your house is on the west, then you can know where it is.
Ah, so for directions? Yeah. Anyone else? I'll take one more. Liana?
It's so you know where your location, like where your destination is.
Yeah, it's going to find where you are, find your destination. We can use it for navigation, finding locations, and our directions. And now, remember, what are these letters for? What are the letters for on the compass? Can we say them together? We have north, south, east, and west. And what's that funny little saying? What's that funny little saying, Sonali?
Never
Never
eat soggy waffles.
eat soggy waffles. Yeah, that's how we can kind of remember the directions. Awesome. So in our classroom, I set it up a little bit so we know where our directions are. We have north, right in the back. North, south,
East, west.
east, and west. And we're going to be using that in just a little bit. So I have some kind of mind-boggling information for you right now. Did you guys know that the Earth is basically one gigantic magnet?
Yes, it
Has anyone ever heard that before?
is. Yeah, it is.
Yeah, maybe? Yeah, so the Earth is just one big magnet, and a magnet is a rock. Earth is like one huge rock. It's a rock or piece of metal that can pull certain types of metal towards itself. And we're going to be talking about magnets today. This is very important. So magnets are pretty cool, and they all have north and south poles. Each side of a magnet, we have a horseshoe magnet picture right here. Do we see the north and the south pole?
Yes.
Well, I have some magnets here too, and they also have north and south poles. These are very important to how they attract or repel different objects. And all magnets, Aman,
I just wanted to say, like with the magnet, like our Earth, that's the magnet. It like when anything gets like a little bit close to it, it pulls it in with like gravity, the Earth. Then it burns in the atmosphere.
absolutely great connection. Yeah, it's just one gigantic magnet. And another cool thing, one second, Abigail. Another cool thing about magnets is that all magnets have something called a magnetic field around them. That's kind of like a force that's either going to pull things towards it or push things away. I don't want anything to do with that. Abigail, yes.
Sometimes I play with my magnets on the fridge, and sometimes when they get really close, it pushes my hands away.
Yes, and you're kind of experimenting with how magnets attract or repel certain objects. Absolutely. So what we're going to do very quickly is I have a couple magnets here, and we're going to pass them along and kind of play with them. See what happens when you try to push them together, or will they attract or repel each other? And then we're going to go over why that happens. So I'm going to pass a couple of these out. Just take a couple seconds to look at it, and then move on to the next person. Hand it to a friend who's next to you, okay? So I'm going to give you some magnets right here, and you guys can watch each other. You can make observations about what you see, and then we're going to kind of talk about it. So just take a second, mess around with those magnets, see what's happening. Yep, so just take a second, and then you're going to pass it to a friend. Awesome, thank you so much, Paris. Luca, make sure you're going to pass it to either Mia or Aiden, please. you noticing with our magnets for everything we've seen so far? If you have a magnet already, you're going to turn and talk to somebody who has also played with the magnet and talk about your observations. What are you noticing? And if you're waiting, I want you to think about this saying, opposites attract. Just think about that. Yes, Mom.
If you put the magnet with like a north and a north, it feels like a north magnet.
I want you to hold on to that thought because we're going to talk about that. Sound good? All right, Avery, make sure the next person does it. Awesome, thank you, Graydon. And if you've had a turn with the magnet, make sure you're talking to a friend about what you're noticing. All right, Sienna, I'm going to pass this one to somebody. Who has not had a magnet yet? Giovanni, I want you to take a look at this. Amanda, you're going to pass that along. Good job.
If you do
Alright, Giovanni, make sure our other friends get a chance as well. Can I pass it along, Amanda? Thank you. Evan, do you need a magnet? Your audio check? Sorry, Alright, and if you're all done with those magnets, Nina, have you had a chance? Nope. Alright. Raise your hand if you have a magnet. Are we done looking at those? I'm going to take them back for now. So guys, raise your hand. I'm going to have you guys share. What were you talking about with your partners? What did you notice? Sienna, what did you notice?
I noticed that like when you put the sides, sometimes when you put the sides together, it wouldn't go together.
Yeah, it wouldn't go together.
And then when you put the other sides together, like each did around.
Very quickly, right?
Like go, and then you would like almost not have the paint hold on to the bottom.
Absolutely. Gabe, would you like to share what you and your partner talked about?
Whenever you put like the star sides together, it would like not like attract to each other. It would like push each other away.
Yeah.
But then whenever you connected one like star side and then the other side that's not like a star, it would like come straight together.
I love what you just said. I'm going to ask you guys to keep your thoughts to yourself for right now. And we're going to talk about why that's happening. That was a great observation, Gabe. The star sides, did anybody else notice that? Give me a thumbs up if you noticed that the star sides did not want to touch each other at all. Yeah. So that's because opposite poles attract. Remember that phrase, opposites attract? So each magnet has a north pole and a south pole. And depending on which one are facing each other, they're either going to attract or repel. And attract means to come together. They don't come together very quickly. Repel means to push apart. So if we have one north pole and one south pole facing each other, so I have one star side and one that doesn't have a star, that's the north and the south pole attracting to each other. They're going to want to come together. But then I heard Amon saying this to his partner, is that if you have two north sides or two south poles facing each other, they are not going to want to touch. They're going to repel. They're going to push each other apart. That's what those two words mean, attract and repel. Come together or push apart. Now, of course, I'm going to bring it back to what we've been talking about, and that is that the Earth is one big magnet, right? It has a north and a south pole. Give me a thumbs up if you know about the north and the south pole. Yeah, so this is the most northern part of our planet, and this is the most southern part. And guess what? Just like a magnet, the Earth has a gigantic magnetic field that's going to push and pull everything towards it, just like a magnet does. Now, I'm going to show you a picture of our wonderful compass. Why do you think, I want you to take a guess, why do you think that a compass is able to work? Knowing what we've been talking about with magnets and the Earth being a magnet, take a guess. What about a compass has to do with the Earth being a magnet? Abigail?
I noticed when I'm cooking, so if you're holding a compass and there's a magnet near it, it can spin it around.
All right. Anyone
And
else?
it
Oh,
works
sorry.
with magnets.
It works with magnets. Would anyone else like to share with that? Aman?
It's like what's it called? It tells you, like, let's say if the Earth was not a magnet, it would not be working because it only shows the way for the magnet. So it's technically connected to the Earth because it is a magnet itself.
It does have a magnet in itself. And do you know what that magnet is? The little needle that points to north. That's how we use the compass, right? It's always going to be pointing north. That's how we kind of orient ourselves. That's how people used to get around before satellites and GPS, right? They would use compasses when they couldn't use like the stars, when it was too cloudy out. They would use compasses that had a magnet, a tiny little needle magnet, to point north, so they always knew where they were going. Wayne, would you like to share?
Yes. So like since Earth is a magnet, does that explain why this is the case? Because
Oh, well, that's gravity, and we're not going to really talk about gravity today so much. We're talking about magnets. So yeah, a compass has a small little magnet in it that is always going to attract towards the North Pole. And today, we are going to make our very own compasses. We're going to see how they work. Sound like a plan?
yes.
All right, I'm going to show you what we're going to be doing very quickly so you know. And then I'm going to have you guys get into groups and you're going to do it yourself. So, I have, and you're going to have, a little cardboard disc. This is going to keep our our compass all together and dry. Our paper clip is going to be our needle, our compass needle. And what we are going to do is we're going to place this this needle, our paper clip, onto our paper, and we're going to create a temporary magnet. This is something that usually can't attract something normally, but when we rub, when we rub a magnet on it a couple times, it's going to be able to be used just like a magnet. So, this is what you guys are going to be doing in your groups. You are going to take the star side and you are going to rub it against your paper clip. I'm going to have you do it 30 times. So you're going to have to be counting, okay? Just quickly, just like this. Can everybody see what I'm doing? And then you are going to see, you're going to put it in the water and see what direction it spins to, just like a real compass would. And we're going to test to see if our magnetic needle is really going to point north, just like a compass would. Aman, do you have a question?
Yeah, I just wanted to say, like, if the Earth was a north and a north, it would be, like, Earth would be split in half because it would go, like, to, like, a whole different place, you know, like how magnets are.
All right, so yeah, that's kind of a more physics question, but we're going to keep focusing on this part, okay? Mia, do you have a question?
Yeah, what are those numbers?
Those numbers, those are like the degrees. Yep, so we're not going to focus on that. We're just going to focus on our letters for directions right now. Abigail, question?
So, yesterday, Lindsay and Olivia at the swimming we were putting the magnets in a line, and then we noticed that the magnets were pushing away.
Oh, they were repelling against each other, right? Absolutely. So are we ready to test our experiments out by ourselves?
Yeah.
Does that sound like a plan?
Yeah.
Oh boy, all right. So, you guys, I put you into groups. Find your name. And then each of you, oh, hold on. I'm sorry. I should have said stay in your seats. 1 second. I should tell you what you guys are doing. So if you have an O next to your name, you are going to be responsible for writing and recording your group observations. I'm going to give you a lab worksheet, and you guys are going to write about what you're noticing, what you see. If you have an M next to your name, you're going to be responsible for magnetizing our paper clip. You're going to do that thing 30 times. If you have a W, you're responsible for putting your compass in the water, making sure it doesn't flip over or get too wet for it to work. And if you have an R next to your name, you are our reporter. You're going to report to the class if your experiment turned out like we thought it would, or if it just didn't, and maybe we can talk about why. So find your name. If you're in group 1, you are going to be, hold on. If you're in group 1, you're going to be in that back corner by the sink. If you are group 2, you are going to be right in the middle and the back floor. If you are in group 3, you are going to be on this section of the floor right here. If you are in group 4, you're going to be over by the whiteboard. And if you are in group 5, you're going to be right here. So get serious.
I'm W. I'm
And I would like one person from each group.
Go ahead.
I would like one person from each group to come get worksheets for your group.
It's supposed to oh yeah. I don't know how to do it.
I'm going to set them right here. Make sure everybody has one in your group.
Why is there 5?
Perfect. Make sure you have
Wait, no. Wait, I'm gonna have to write everything on here. Like this? No.
Group 1. Can someone come get a water bucket?
Wait, Miss Frank, do I have to write all
Group 2. Someone come get a water bucket. Group 3. Can one person come get a water bucket? You group 3, Gina? You group 3? All right, group 4. I need you to have one as well. Are you guys group 5, right? Group 4? You need one as well. Everybody make sure your water bucket is on the floor so we don't spill it anywhere.
I'm the reporter.
Hold on, I'm going to give it to you. All right, can everybody look at me really quickly? Boys over here, can I have everyone's attention? Take a look at your lab worksheet. While I'm passing out your compasses that you're going to be working with, I want you guys to take a look at that first question. Make a prediction. What do you think is going to happen? Everybody should have it written on their worksheet.
I think it's north and west, south, or
We are in North America, but that is for the directions. That's just north.
So, guys, it's gonna go north. Go be living in North America. If it doesn't, it'll go. No, so it's either north.
You guys should be writing what you think is going to happen.
Because we live in North America. No, I think it's gonna go left. No, it has to go north. No, it has to go north. Oh my gosh. It's gonna go to north. I think it's south. I'm not saying it's gonna go to west. I know the closer you put up, I think wherever the set, it's gonna go.
Alright, I guess we'll find out.
So I think we have to try it first. Alright. Wait, Delano, I don't know yet. We don't know yet. And make a prediction. Book it.
Alrighty. Give me a big thumbs up. Give me a big thumbs up if you have your magnet and your compass and your predictions are ready. If you guys have made your predictions. Are we ready to do our experiment, everybody?
Yeah.
So, I need my M's, my magnet people. I need my magnet people. I need you to hold up your magnet on the side of the star. On the side of the star. Take your compass and you are going to, just like I did, you are going to start at the tape side and rub your magnet across it 30 times. 30 times. You're starting from the tape side. Yep, awesome. Make sure you're rubbing with the star side down. You're going to and then you have the water, so I want you to put it in there. You guys should be putting it in the water after you've rubbed it 30 times. See what direction it's going to. Go ahead, Sonali. Which way? Take a look at that.
Look at it. It's going down.
I'll give you a hint. Oh, maybe.
It's facing north. It's facing north. North. I knew it. Wait.
Oh, thank you.
That's where the water goes.
Take a look at that. It's pointing north. It's turning. It's looking north. Take a look at that.
I told you the tape side was gonna go north.
So that is pointing. That's pretty north. Take a look at that.
It's somewhat northeast, but if you were to go like that, it's like it's so
I'll give you a little.
it's like northeast.
I'll give you a little inside information. If you're looking straight across to the board, it's not exactly north. You turned a little bit. That's gonna be north. But I had to put paper on the wall, you know.
How do you spell north?
Okay, everybody, take a look up here.
N-O.
Has everyone been able to try their experiments? You guys are still working? Oh, I see. Okay. No big deal. So take a look. It's turning around. Awesome. How do you what?
Yeah, it's getting dark. It's like
All right, guys. If you have been able to do the experiment, take a look at that third question. Tell me what direction your compass pointed to.
North.
You're going to write it down on your paper. Awesome. So I want you to write your observations that you noticed about it. How did that work?
Down, so it's not gonna move anymore.
Yep, so you guys are going to all kind of help each other. But Nina, if you spotted anything super cool, you can tell it to your group.
I'm making it cute. That's not how you do CPR. Look, this is how you do CPR. Bro! That's how you do CPR. You don't do it like this.
If you are done with your experiment, you should be filling out the rest of your worksheet.
Yeah, because
Don't forget to talk about what you saw.
you don't need to have that. Why do you say I like that one. You don't like that one. Right here.
I just wanted to ask you.
No, yeah, why does it right there? Number one, number two, number three. What do you mean?
Spun around different directions.
No, yo, this says that. What? Yeah. Okay. Yo. It was correct, but you said this.
And this is our south.
Yeah, you just circle three.
Because we're facing towards the front of the room.
Kind of low.
I wish you keep working on your And I know you guys are kind of like,
no, we
make sure you write some observations on what you saw. How fast was Isn't that cool? How are we doing with our lab reports, everybody? Yeah, it's just cardboard. It's gonna get wet.
Yeah.
Yeah, it's rounded. It's so
Then I want you to just write the sentence what your result was. That's what that third thing is. How are we doing, everybody? Are we working on our observations right now? So I think I remember hearing about your group that it pointed north, right? We all wrote that in our third question, right? This is where we're telling our results. Observations, so that's what you noticed during the experiment.
I noticed that it pointed north.
You noticed that it pointed north? All right.
Wait, I thought that was mine. Your pencil's back there.
Oh, yep, we got one.
On the ground.
Oh, thank you.
Okay, I'm going. It's only 50 cents. It's only 20 cents. Well, I give it one. No, you owe me $1. I didn't. I don't have. And then you owe me $100. My brother owes me $100 because he has only $100. He said that was a good. I noticed that it was north. Water 10 times.
Yep, after we banged his head to the needle.
Hey, what's that? I know the white. I know this is north.
Remember your observations and what you noticed during the experiment.
How do you?
I really don't
Wait, what's your point
Are you guys all set with this? Oh, I see what you're saying.
That's a board. That came out from the board.
Guys, I'm gonna give you about 1 more minute to finish up your lab worksheet. Nope, you're gonna hang on to that for right now.
How is it
Yep.
yours?
Are you guys all set with your lab? You guys all set? Okie doke, everyone. It looks like people are just about done. So I'm going to ask you to please go back to your seats, bring your lab worksheet. You're going to hang on to that. Thank you, Mika. I got it, Magnet. Can someone get me a magnet? Suddenly, you can put that on that table right there.
Do you have the magnet?
Do you have a magnet? So guys, we're going to discuss about what we noticed, what were our observations and results. You're the reporter? Okay, go back to, everybody's going back to their seat. Thank you. Everyone's going back to their seat and hanging on to their papers. Now here's where my reporters come in. When people are in their seats and ready to share, we will see how people's experiments went. So my reporter for group 1, who is that? We have Abigail. Was your prediction successful?
Yes.
Where did your compass needle point towards? It turned north. Did you have any cool observations from your group?
First it went west, then it turned north.
So it kind of had to slowly move north?
Yeah.
I see. All right, group 2. Who's our Sienna's our reporter. Was your prediction correct?
Yeah.
Yes. Any observations about what you guys noticed?
That it started south, then north, and it stopped at north, and it went really slow.
Kind of went slow. I like it. And Giovanna, for group 3, you're our reporter.
I noticed that alongside the left, I noticed that it pointed to north. I also noticed that it sank at the end.
Oh, yeah, that's because I was just using cardboard to keep our magnets, to keep our compasses not wet. Okay, Gabe is our reporter for group 4.
Our prediction was successful. It was going to point north. An observation that I noticed, and I mainly noticed only, it's mostly bent down. Ours was mostly bent like down towards the north side.
Like
And it was
your
pointing-
needle, your compass needle?
Yes, and it was
Okay.
mostly like pointing up, towards south.
I see. Very cool observation. And lastly, group 5, we have Jake as our reporter.
Basically, our compass basically sunk, and the paper, but the tape didn't really hold it.
So were you able to see if your compass acted like a real compass?
But it didn't go as planned because it didn't stop at north, instead it stopped at east and then started going again.
Started going again. Did it
So
ever?
basically, it was just endless. It never stopped.
Endless, I see. So it never really hit north?
No.
Well,
It never
you know
really
what?
hit north. It hit north a couple times, and then it just went all the way up to west, then south, and then all the way. It didn't go as planned.
I see. And you know what, guys? That happens sometimes during experiments. That happens all the time to scientists. They try figuring out new ways to kind of solve those problems. And they try again and again and again until they see if their predictions are ever really right. Evan, do you have something to share? Or are you stretching? No? All good? All right, guys. So I hope you liked doing the actual experiment, because I thought you guys did an awesome job on that. And now I have a, oops, I'm sorry. Now I kind of want to ask you guys, how does knowing about how magnets work help us understand how we would use a compass? What's so important about magnets that kind of let us do this experiment? Any ideas? Remember, what part of the compass has some kind of magnetic thing going on with it? Gia?
The star part or the shiny part of it?
So that's our actual magnet, but what about our little compass? Donnelly?
Paperclip?
Yeah, the paperclip. And the paperclip represented what? Sienna?
The needle.
The needle in a compass, exactly, yeah. So knowing how magnets work, how one pole is attracted, so this means that this is the south pole of our compass. The south pole is attracted to the Earth's north pole. Its poles, it's attracting towards that side, and that's how we're able to kind of use it as a direction. That's how it tells us where we're going. Does that make sense to everybody?
Yeah.
Does anybody have any questions before we do one last thing? No? All right. I have one more thing for you guys. And this is just a quick little exit slip just to finish out our experiment. You guys are going to work on this by yourself. And it's about what we just did. Sound good? I'm going to have my odd numbers come get one right now. Here you go. Here you go. You're welcome. Here you go. And my even numbers can come line up behind them. Make sure your names are at the top of the pages because I'm going to collect this to see what you guys kind of learned during our experiment. Here you go, Gabe. Giovanni. Here you go, Brandon. Brandon. There you go. Oh, thank you so much. Oh, you're going to hang on to that for right now. And you're going to work on this. You guys are kind of showing me what you know, what we learned. How a compass and a magnet are kind of one and the same. Sort of. We use magnets to use compasses. Amanda, you have a question?
Yeah. I just wanted to ask, what do you think? Yeah. What does it mean, the two sides of magnets are just called?
Remember when we were testing out our magnets at the beginning?
Like that?
Yeah, and then you said something really good about that.
Yeah,
The two sides?
yeah, I think I know.
Okay. So remember, guys, attract means to come together, and repel, and repel means to push apart. So keep that in mind as you're writing. And when you're all done with your exit slip, you can put it right here on the brown bench. And then I'm going to have you go on your iPad and you're going to take a look at Epic Books for a second. That's going to be our next step when we're done. You know what? I'll take this too. And I'm sorry, this is a last minute thing. For your labs, I'm going to have you put it on the blue table. Your exit slip goes on the bench, and your labs go on the blue table. And then you're going to take out your iPads, and you're going to start reading some books on Epic.